So polynomial long division kind of follows the same idea as our traditional long division does. So I really want to focus on long division and the steps to doing the standard long division algorithm. An algorithm is simply a set of steps that get us an answer. So if I have a question like this, I think about I have the thing that is being divided in here. So originally this problem would probably look something like 1,573 divided by 13, right? So the thing that's being divided goes inside of the little radical sign. It's not a radical sign, but it goes underneath, and then the thing we're dividing by goes outside. So 13 does not go into 1, but it does go into 15. So I would write 1 times 13 is 13, so I write 13, and then I subtract, I take away. 15 minus 13 is 2, and then I bring down the next place value, so that becomes a 7. And then I start again, and I'm going to change the color so that I remember that I'm doing this. This is my next round. So I think to myself, 13 times what gets me 27? Well, 13 times 2 is 26. Oh, that's close, but just under. So I got to put a 2 up there, and I'm going to do this in blue. 2 times 13 is 26. Then I subtract. I'm left with 1. The 3 comes down. And my last step, what times 13 is 13? 1 times 13 is 13. When I'm done, I have 0, so this is a remainder of 0. So I start thinking about division in a similar way, where I have the thing that I'm dividing by outside, the thing that is being divided. So this problem would probably actually look something like x to the power of 3 plus 5x squared plus 7x plus 3, all divided by x plus 3. Now, the numerator is the thing that I'm being divided by, so I'm going to start thinking, does this x, how many times does this go into this? Well, it doesn't go in there any times, but this starts going into this first two terms. Well, x times something is x cubed. So x times something is x cubed. Oh, I know. That's x squared. So I think x squared times x is x cubed, and x squared times 3 is 3x squared. So 3x squared. And now I subtract everything. So x to the power of 3 times x to the power minus x to the power of 3 is 0. 5x to the power of 2 minus 3x to the power of 2 is 2x to the power of 2. And then my next term comes down, plus 7x. Now I repeat this process. I think, what times x gives me 2x squared? Well, what times x gives me 2? So 2x times 2 is 2x. Oh, 2x times x is 2x squared. So 2x times x is 2x squared. 2x times 3 is 6x. And then I subtract. Everything's getting subtracted. 2x squared minus 2x squared is 0. 7x minus 6x is 1x. And I bring down the next term. How many times does x plus 3 go into x plus 3? Oh, that's a 1. So it goes in 1 time, and I'll do that with green. 1 time. 1 times x is x. 1 plus times positive 3 is positive 3. I subtract. My remainder is 0. That's where we want to be. This is very similar to the traditional division algorithm. We know all of these are positive, and this is my answer. We're just going to practice a few different problems using the long division algorithm. Something I want you to particularly pay attention to, what in this problem do you notice about the powers? And I'm specifically talking about this numerator, or the top of the fraction. What do you notice? And hopefully you saw, oh man, there's a missing place value. We've got x to the third power, x to the second power, but we're missing a 0x. So I'm going to actually add that in. And just like with the tabular method, this added in piece is really, really important because it holds our places so that when we do the long division, we have enough space. I'm going to go ahead and move this over so that we have enough working space to work on. When we do this, remember the thing we're dividing by goes on the outside, so 2x minus 2 goes on the outside of the division problem, and then what goes inside is what is being divided. So in this case, it's the 2x to the third minus 4x squared. We have to add in that 0x and plus 2. So make this all clean. And again, I'm going to do things in red, so I'm thinking to myself, something times 2x is 2x cubed. I know that to be x squared, because x squared times 2x is 2x to the power of 3, 2x to the power of 3, and then x squared times negative 2 is negative 2x squared. Here's where it gets tricky. Before, we were supposed to subtract all of this. Well, this subtraction sign goes to this, and the subtraction sign also goes to that. So we have 2x cubed minus 2x cubed. That ends up being 0. But when we do it with this, we have to be really, really careful. Negative 4x squared minus a negative 2. So a double negative is kind of like a positive. So it's negative 4x minus a negative 2. So it's kind of like negative 4 plus 2. So this should be negative 2x squared. Take a minute, if you didn't get that, pause this video so you can really see what we're talking about here. When we finish that problem, we bring down the next term plus 0x, and we can move on to the next one. I'm going to switch colors for the next color. So I'm thinking, what times 2x gives me negative 2x squared? So if I need a negative, it's got to be a negative something. Negative 2 times, negative 1x. So it's kind of a guess and check game. So I've got negative 2x squared, and then negative x times negative 2, double negative again, that becomes a positive 2x. And then again I'm subtracting, and when I'm subtracting, it's negative 2x squared minus negative 2, like a double negative. That ends up being 0x squared, or just 0. And then 0 minus a positive 2 is minus 2x, or a negative 2x, and then the next term comes down. It's positive 2. What do I need up top? What do I need up top so that this times the thing I'm dividing by gets me this? What gets me negative 2? Oh, that's got to be negative 1. So I'll do that in green, negative 1. Negative 1 times 2x is negative 2x. Negative 1 times negative 2 is positive 2. When I subtract everything, negative 2x minus negative 2x is 0. 2 minus 2 is 0. I have no remainder. My final answer is this stuff that's on the top of this division problem. So I just want to do one more with you. The first thing I want to check is to make sure that all my place values are there. It looks like it is. I'm just going to do this as quickly as I can, trying to explain as I go. X plus 5 goes on the outside. This 2x cubed plus 11x squared plus 7x plus 10 goes inside here. I think what times x gets me 2x cubed? It's got to be 2x squared. Maybe I should do this in a different color. 2x x squared, because 2x to the power of 3, 2 times 5 is 10x squared. I subtract 2x cubed minus 2x cubed is 0. 11x squared minus 10x squared is 1x squared. And I bring the next thing down. I'm going to change colors. I think what times x is x squared. That's got to be x. So x times x is x squared. X times 5 is 5x. It's a positive 5x. It's a positive 7. I forgot to write that. I'm going to go subtract. X squared minus x squared is 0. 7x minus 5x is 2x. Bring the next thing down. So plus 10. And then I think something times x is 2x, so that's got to be 2. 2 times x is 2x. 2 times 5 is 10. And I get 0 and 0. And then I'm done. And so this, when I add the signs, it's a positive x and a positive 2. This is my answer, 2x squared plus x plus 2. Let's just do a couple more. I just want us to get into the habit. So if this is the division problem, I think what times 2x squared gets me 2x to the fourth. That's got to be x squared. So 2x to the fourth. X squared times negative 3 is negative 3x squared. Uh-oh, I put this in the wrong place because my x squares don't line up. I have to put this underneath the term that it goes with. So x squared times negative x squared, negative 3x squared. Now I have to subtract. And it's all going to come down. So 2x to the fourth minus 2x to the fourth is 0. The 14's got to come down, 14x cubed, because we're subtracting nothing from it. X squared minus negative 3, that's a double negative, so that ends up being 4x squared, because minus a negative 3x squared is positive. It's like adding. Okay, I'm going to do the next round. Something times 2x squared is going to give me 14x cubed. It's got to be 7x. So 14x cubed. Then 7x times negative 3. I probably got to bring that down to negative 21x. 7 times negative 3 is, it ends up being negative 21x. This is handy. I like how this is turning out. Now I subtract everything. Zoom back out for a second. Subtract everything. Remember, there's a 0. There's an invisible 0 there. Something minus. So we've got 0. 4x squared minus 0 is still 4x squared. Negative 21x minus negative 21x is 0. And then the negative 6 comes down. That's a 6. And then my last round, I have to see something times 2x squared. That's 2. 2 times 2x squared is 4x squared. 2 times negative 3 is negative 6. Beautiful. This kind of, even though it's a little bit wonky, it all comes out. 0, 0. My answer is this stuff up here, x squared plus 7x plus 2. One more. We want to know if this is a factor, if x plus 3 is a factor of x cubed minus 27. And so we can explain this using the long division algorithm. Notice that I've got missing place values. I probably want to put in zeros for that, so I would do x plus 3 being divided by x to the power of 3 plus 0x squared plus 0x minus 27, just so that I have all my place values in there. So x squared makes it x cubed, and 3x squared. So we've got 0 and negative 3x squared. Bring down the 0x. So something times x is negative 3x squared. So negative 3x. So that's negative 3x squared. plus, minus 9x, because negative 3 times positive 3x is negative 9x. We've got 0, negative 9. Oh, we're subtracting, so double negative, that's a positive 9x. Bring down the 27, negative 27. And we find that that's got to be a 9, right? Because 9 times x is 9x. 9 times 3 is positive 27. Uh-oh. When we go to subtract this, this goes away, but this actually becomes like really big. Negative 54. Uh-oh. So it turns out that this is not a factor, because the division doesn't come out nice. If the division came out nice, it would be a factor. This is kind of an extension question, but you can use division to help you explain whether or not something is a factor of something else. I hope this video was useful. Long division is kind of a lot of steps, and it's really just going to take some practice. Maybe rewatch a couple of these videos, do several practice problems. Those should really be helpful to you. Good luck.